Hi everyone, this is Hossein from IJA Academy, and Amir is with me here today. He's
Hello,
going to, hey Amir, how are you today?
I'm good. How are you?
I'm good, thanks. Amir is going to help me to solve another problem in calculus. This is a derivative problem. So he's going to help me to find the derivative of an inverse function. The inverse function is a nested arctangent. So Amir, floor is yours. So
Okay,
you can go ahead.
sure. Yes, we have arctangent of arctangent of x. So let's see. On the side, I'm gonna write the simple arctangent function. So when we have y is equal of arctangent of u, then y prime, which is dy over dx, is u prime plus divided by 1 plus u squared.
So u
So
here is what? Is that
is
independent variable or is a function of another variable?
this is a function of x.
Okay.
Yeah.
So when you say u prime means
In terms of
du
x, yes,
du to dx. Okay.
correct.
And y prime is
Y prime is also dy over dx,
dy
correct.
over dx. Okay.
So prime means the derivative in terms of x.
Okay.
So given this relation, I mean, I'm gonna consider this as u.
Okay.
So here I write down the derivative of y in terms of x. So it's u prime, which is this guy here. So I'm gonna simply write tangent inverse of tangent inverse of x prime. So the derivative of this guy in terms of x
This is your
divided,
u prime.
yes, that's u prime, which we have here,
Right.
divided by 1 plus u squared. So again, this function,
Arctangent of x.
yes, squared.
That's great.
Yeah, so denominator is simple. We don't need to do anything. For the numerator, I'm gonna write it down here. So
you have one more step, finding the derivative of u.
correct. So the derivative of this guy, tangent inverse of x. Again, we can use this relation here. This time, we can call this as u, correct?
Do you want to use another variable just to avoid confusion?
Okay, I call it w. Is it good?
Okay. Yeah, that's good.
So w. So it's going to be w prime,
right,
which is tangent inverse of x divided by 1 plus w squared.
which is tangent inverse of x.
Correct.
Mm-hmm.
And this the numerator is simple because we know that when y is tangent of x, in tangent inverse of x, y prime is 1 divided by 1 plus x squared.
Right.
Yeah, so given this one,
Mm-hmm.
I can write, let me write it here.
Just needs to substitute
Yes,
the numerator for that expression.
correct. So let me first write the denominator,
Mm-hmm.
tangent inverse of x squared, and then for the numerator, I have 1 divided by 1 plus x squared.
Correct.
So let me write it down like this. One plus times
1 plus tangent inverse of x squared. Okay.
So
yeah,
I think it's easier to digest.
Right.
So instead of this guy in the numerator, I'm gonna put this expression.
Right. Just plug it back to the first equation.
If I call it equation number 1, if I call this one equation number 2,
Mm-hmm.
From 1 and 2, we can conclude the following.
Mm-hmm.
From 1 and 2, we can say y prime is equal to, okay, I first write the denominator here.
Mm-hmm.
So it's going to be 1 divided by 1 plus tangent inverse of tangent
Inverse of
x
squared.
squared
Okay.
times
Mm-hmm.
this guy, which is in the numerator here.
Which is equation number 2.
That's correct. So times 1 divided by 1 plus tangent inverse of x squared times 1 plus x squared. So
yep, that's the answer.
Yeah.
Yeah, that's you got it. All right. Yeah, thank you, Amir.
Okay, it's not that scary.
Yeah, it's just tedious,
Correct.
So to summarize, I guess you use change of variable to solve this problem. So you rename the interior function as u, and then you use that equation that you wrote on the side. You found the derivative, and then again you use that equation one more time to find the derivative of the interior function, which you call that w, and you combine all those equations and you got the final answer. I think we need to do maybe do another video solving this problem again without this technique, without using the change of variable for those viewers who are not familiar with this technique, which is called change of variable. Yeah.
Sure.
So yeah, thank you, Amir. I appreciate it. And for the viewer, if you like this video, if this video helped you to understand the calculus better, please consider subscribing to our channel and hit the notification bell for future video. Until next video, bye everyone.
Bye. Thank you.